Hello students, welcome to Dr. Shourab's classes. So in this particular video we can see we will solve the free response questions, that is the FRQ of AP Calculus BC. Okay, now before moving on to the question, so we will look into the things of what is this FRQ, that is the free response questions. So for many students this is one of the most challenging section of an advanced placement. So this is one of the most challenging section, and also it is it's comprised a significant amount of each exam's overall score, and so you can say it's most of one of the challenging, and as well as a very improvement of the overall score is needed, so we have to focus on this particular FRQ. Okay, and if you would think that if you're concerned about this thing, that is a so this is a significant amount of the overall score. So if you people are somewhat this concerned about this particular thing, how to improve this thing, how to improve our score in this particular sector of advanced placement of FRQ, so here are my 5-point strategy, so which we will follow. As I will follow in solving this question, you will learn from this also. So this 5-point strategy, if you follow well, then I think then it will be easy for you to keep a good and high score, a good score on the particular FRQ section. So first strategy is read each free response question carefully. So you need to know what the question is asking for. You have to answer that in that manner only. So next, point number 2, strategy 2 is the maximize points on the multiple part question. So the multiple part questions. Point number 3, you share your thought process, what you are thinking about the problem and what is your approach in solving the particular problem. And your approach should be, nothing should be any complicated term, it should be clear and concise, which requires to get this particular point number 4, it requires a lot of practice to get this point of clear and conciseness. And the fifth strategy is usage of proper penmanship. So this is the, we'll follow over here also, and this, if you remember this, or if you carefully look into this 5-point strategy, and if you follow this particular 5-point strategy, so you will get a score on the high end, and that is for sure. And to gain this 5-point strategy, the only thing that is required, you need a lot of practice. So now we will move on to the, so that's all the part of the FRQ questions, and now we will move on to our question number 3. And remember, in this question number 3 is graphing calculators are not allowed. So previous 1 and 2 question, you can see that the graphing calculators are allowed, but for this particular thing, this graphing calculator is not allowed. So let's see the question number 3. So it is saying that a company designs spinning toys using the family of functions, that is y equal to cx root over 4 minus x squared, where c is a positive constant, and the figure above shows the region in the first quadrant bounded by the x-axis and the graph of y equal to cx root over 4 minus x squared. This is the graph of this y function for some c. So each spinning toy is in the shape of the solid generated when such a region is revolved about the x-axis. So both x and y are measured in inches. Got that right? So this is the question number 3, and this is the graph, and each spinning toy, you can see, is in the shape of the solid generated when such a region is revolved around the about the x-axis. So what is the, so we have these multiple parts questions are there, A, B, C, and we will look into this one by one. So first let's check with the question number 3a. So we have to find the area of the region in the first quadrant. Okay. area of the region we need to find in the first quadrant bounded by the x-axis and the graph y of cx root over 4 minus x squared. C is a positive constant, you know that, so for c equal to 6 you have to find the area of the region. Now so we have to find the area, so it is given y. So let's take this problem in this manner. This part A, we have been given the graph of y as cx 4 minus x squared. C is already given over here as 6, so we can directly mention over here that 6 x root over 4 minus x squared. If we put this equal to the 0, okay, so here we can find the two values of x, that is x equal to 2 and x equal to 0 and x equal to 2. Okay, so what will be the area over here? So the area is integral 0 to 2 6x 4 minus x squared dx. So that is the area of the region in the first quadrant. Okay, so here you have find the integrand. Okay, now let us take u be 4 minus x squared. So we will solve this actually right now. Okay, so what will be du? So du is nothing but minus of 2x dx, so which is minus of half du equal to this x dx, right? So now we have two values of x, so we will check with first one, x equal to 0. So for x equal to 0, it will be u will be 4, right? This 4 minus 0 square we can write it, so it's 4. We have to write it in this manner only. And for x equal to 2, we have this u equal to 4 minus 2 square, which is equal to 0. Okay. Now putting this value over here, so it will be simply integrate of 0 to 2 6x, right, 4 minus root over 4 minus x squared. So we can write it in this manner. This will be for x equal to 0 to 4, okay, 6 of minus half root u du. So from here you can get minus of 3 integral 0 to 4 is integral 0 to 4 u to the power half du. So 3, and just with the minus you can lower integral to upper 0 to 4, it can be done. So u to the power half du. So now doing the derivative, there's doing the integral anti-derivative. This is, so this is 2 u of 3 by 2 from e equal to 0 to e equal to 4. So if we put the values over here, it will be 2 over here and it will be 8, so 16. So this you have find the anti-derivative, right? So finally the answer, so what will be the answer? Write it in this manner also. So the area of the region is 16 square inches. Okay, so for this part you can say that, so this is 1 point and you have derived the antiderivative, so for this it will get 1 point, and the integrand you have determined, so this will 1 point, so total 3 points over here. Now what is the question saying for part B? It is known that y equal to this cx root over 4 minus x squared dy dx is given. For a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. So what is the value of c for this spinning toy? So to determine the value of the c. Okay, so let's solve this part B. So the cross-sectional circular slice with the largest radius occurs where cx root over 4 minus x square has its maximum on the interval 0 less than x less than 2, and so this will be, we have to set, okay, so this is the set dy dx equal to 0. So if we put this set dy dx equal to 0, so we have been given this dy dx is equal to c of 4 minus 2x square by root over 4 minus x square. So this equal to 0. So from here we can get the value of x is equal to root 2. So here we can given the set dy dx equal to c. Now we have to find the value of c. So once we have find the value of x equal to root 2, so this, so x equal to root 2 is given. So from here we can find the value of y. So y equal to c root 2 root over 4 minus root 2 square. So that is equal to simply 2c. So 2c is equal to 1.2. So c is equal to 0.6. So that is the value of the c. So here we have solved the two parts. You can see first we have set the xy dx dy equal to 0. So this goes for 1 point, and we have already calculated the value, we have find the value of c. So that's for 1 point. Okay. So let's move to the last part of the question, that is part C. So we have this for another spinning toy. The volume is 2 pi cubic inches. So what is the value of the C for this spinning toy? Okay. So you have to find the volume actually. It's given the cubic inches. Okay. You have to determine the volume, and then from that volume we will find the value of C. Okay. Let's take this. So we are solving the part C over here now. So volume can be expressed as, it's 0 to 2 pi cx root over 4 minus x square whole square dx, and we can write it as pi of c square, it is 0 to 2 x square 4 minus x square dx. Okay, so this is the form of the integral. Form of the integrand. Okay. Now solving this, we have this pi of c square, so we can write it as pi c square. So it can be simply written as 0 to 2 x square means 4 of x square minus x to the power 4 dx. So which can be written as pi c square, this is 4 by 3 x cube minus 1 by 5 x to the power 5, 0 to 2. Okay, So this is the antiderivative we are finding. Now solving this particular value we will get, so pi of c square, so in that case we will get 32 by, it will be 3 minus 32 by 5, so which will be 64 pi c square by 50. Okay, so this 64 pi c square by 15 is equal to 2 pi. So from here you can get the value of c square is equal to 15 by 32. Okay, and c is equal to root over 15 by 32. Okay, so that is the thing. So this is the value of the c. So this is the answer for part C. So from here the points distribution will be, so first you have the form of the integrand, so the limits and the constant. This is the 2 points, 1 plus 1. So next is the, you have to find the antiderivative, so it is from here we will get this 1 point, and finally the value of this answer, we have this evaluation from this part, so it will give you up to this part the value of the c. This is 1 point, so total 3 points we have over here. So this solves question C, question 3. So where the grading calculators, graphing calculators are not allowed.